In this video, we will be taking a look at the basic concept of process capability with some examples to help. Let's start by understanding what process capability is. In this example, there is a measure on a part that we are interested in. We also have a tolerance specification for the measure. For each individual measure, it is possible to determine whether it is in specification or not just by comparing it to the specification. However, what if we want to determine the performance of the overall process against the specification? This is what we mean by process capability. Here is an example for a formula for calculating process capability. The allowable tolerance is divided by the range of data. This means that for any value above 1, the acceptable tolerance is greater than the data spread. This means that the process is capable. If it is less than 1, this means that the process is not capable. To help explain process capability, I'm going to be using the example of a parking space. The lines of the parking space are effectively our tolerance. Now let's see how our process capability changes when we park a range of different vehicles in the space. Imagine each vehicle has the range of data, i.e. the variation. We'll start with the average car. This has good capability. The space is bigger than the car, therefore the capability will be greater than 1. For a motorbike, driving into the same space, it is even narrower than the car. The range of data is much tighter. The result is the process capability will be even better than what the car had. Now we'll take the tank, trying to fit it into the same space. The tank is clearly wider than the space. Therefore, the process is not capable. The capability will be less than 1. The only way we're going to make this process capable is by either shrinking the tank or widening the space. In these examples, we have made the assumption that the variation is centered about the nominal point. The vehicle has always been parked in the middle of the space. However, in reality, this is not always the case. Whilst most people can park somewhere between the lines, from time to time, we do come across that one person that might park their car a bit like this. The same applies to variation in general. In these cases, the calculated mean from our data does not equal the nominal specification. This is often referred to as mean shift. When calculating process capability, this needs to be taken into consideration. To do this, we need to not only consider the range of our data, but also where it lies relative to the specification limits. This is where further process capability calculations come in. This time, we are calculating the capability of the process to each specification limit rather than the specification width. As a result of this, we end up with two numbers. The process capability result is the lower of the two. Taking these two cars, even though they have exactly the same width, one is clearly more capable than the other at parking in the space. I hope this video has given you a fundamental understanding of process capability with some basic calculation methods. Please look out for my next video where I will explain how we calculate process capability using indices. In the meantime, please check out my channel and other videos including how to calculate variation.